Myself, Dr. Ajay Giri from India. I must express my gratitude to the organizer and the distinguished experts from the globe. This is my work. I like to share with you that currently I am working as an associate professor in the University, Bundelkhand, Jhansi, India, and I have been working in this sustainable management of industrial waste, and then currently we are working on this phytoremediation of domestic sewage. But I think when I am going to discuss with this phytoremediation aspect of our solid waste and also the domestic sewage, I like to submit before all of you that India is one of the highest populated countries in the world, having 1.4 billion populations. It means that we have huge amount of domestic sewage produced in our cities. And that is the major issue in our environmental aspect. In our regions, like most of the cities are having some serious problems, and that we like to get a amicable solution. That is, the phytoremediation is one of the eco-friendly approach, and that is one of the very cost-effective. And in present context, we need to get a solution where is synergistic remediation of waste with resource recovery is one of the major interest that what we are thinking for. So this discussion I would like to explain, and I think my work will probably explain the very effective techniques that how we can solve this present issue, with many of these problems can again have end up with this that is the some resources which will be very much useful. So for the current context, that is the in form of my presentation. Now I will be coming to my discussion with the slide one after one. This is the brief form of my discussion, and I like to share with this graphical abstract where I like to mention that in India we have a huge population, as I told you, around 1.5 billion population, where residential waste is one of the very serious challenge. And secondly, the serious infrastructure deficiency, that means with lack of infrastructure facilities, and then huge urban population increase is one of the major issue where we are facing this problem to deal with this so much of huge quantity of this sewage flows. And now in my work, what we have done is that residential waste is one of the important sewage human residential areas concerned with, and where we can make use of that sewage flows by doing some eco-friendly approach, where some emergent macrophytes in my work, that is the phytoremediation of that waste in presence of emergent macrophyte, that is the Typholatifolia. And the next step, that Typholatifolia allows that waste to be treated to the extent which is very much attractive for algal productions. As you know, that algae is one of the very untapped resources throughout the globe, and India being diverse climate, we are enjoying the diverse climate where we have diverse varieties of the algae flora, and also the some emergent macrophytes and some other types of tree species also, which can be very much effective tool technique, which will be very environment friendly, and that we can make use of that resource to treat our waste, and which is one of the very much demanding and very much eco-friendly approach, that we have to look into that. And today our work, our focus is to have practice to come into a perfect condition to set up our techniques, tools, which will be effective for our future treatment of the wastewater, because this wastewater is creating a serious challenge to our environment, where people are seriously affected with chronic problems like some waterborne diseases and many other epidemic diseases. So our present talk will discuss on that how and what we'll be doing, and that the next step. What I like to tell is that in case of phytoremediation, you may ask that why phytoremediation is required in India. And I think poor infrastructure with rapid urbanization is the chief causes of dumping of untreated domestic sewage in the environment, and thereby posing serious public health and environmental concern in India. Also, recently our Central Pollution Control Board, the data which indicate that around 28% of the generated waste sewage flows, that is around 72 billion liters of sewage which is generated every day, and thereby around 72% of the untreated domestic sewage has been accumulated, because around 28% is only treated. And the consequence is that around 75% of these domestic sewage which are accumulated on the surface water bodies and causing the risk to our ground and surface water resources. And here is one data which depicts the 12 different states, which indicates the present scenario. You can find from this graph that we have some selected states where you can find the blue bar lines indicate the amount of domestic sewage generated, and the brown bar lines indicate the amount of waste sewage flows which is treated. And I think it will be sufficient to indicate that it's a very, very low amount, very insufficient infrastructures which not able to give the services of treatment of domestic sewage, and thereby causing serious present and future risk to our national environment. This is the summary. I can tell that this graph indicates that around 72 billion tons of sewage flows generated on an average every day in India, and here only 12 billion tons is having the complying the treatment standards. So you can think of how much risk that we are undergoing in India. So to have this type of problems in our hand, we have to look for a sustainable management of our solid waste sewage flows in our Indian environment. Now, why to engage phytoremediation in India? Again, I like to tell you that India is gifted with plethora of aquatic plant species occurring naturally as wild plants in surface water bodies. For environmental cleanup, conventional sewage treatment is energy intensive, while highly complex and expensive to set up and operate. However, engaging aquatic plants in eco-friendly phytoremediation techniques are simple, efficient, and cost-effective for synergistic remediations and resource recovery from sewage, thereby highly desirable for India. Now, why to employ phycoremediation after phytoremediation of domestic sewage? Here you can just look at these three important issues where we like to engage this phycoremediation after phytoremediation. The first point is that algal cultivation devour nutrients from pre-treated sewage. The second point, the concentrated raw sewage with high total suspended solids, carbon nitrogen ratio, toxic pollutants, imbalanced nutrients, and dark colors are the major limitations. Those inhibit the growth of microalgae in fresh sewage. With all the above perspective and problems, phycoremediation is attractive to employ after phytoremediation of raw sewage with an emergent macrophytes in a vertical flow constructed wetlands. Now, I like to take you to our areas in the local areas in our cities. We are having plethora of aquatic macrophytes, and dominant among that macrophytes, there is one Typha latifolia and Eleocharis. There are many more macrophytes, that aquatic macrophytes. We are rich with that resource, and we have not yet used that capacity and capability of this aquatic macrophytes. And with this, we have started this work since last 1 decade, and now we are in a position to deliver some techniques and some tools where we can very nicely, very effectively, we can treat our waste, and in return, we can get a very good biological asset where we can feed our cattle population, can prepare food for some specific purposes, some specific, I think we know that some of these fertilizer fuel can be also produced from this aquatic macrophytes after growing by harvesting from that treatment process. That is why I like to wish to thank macrophytes for many reasons. As I told you that macrophytes have many more benefits in blessing in disguise. That is efficient for removing nitrogen, phosphorus from the sewage, serve good resource as a raw material for food, fodder, and fertilizer, provide habitat for wildlife species, fish and animals. Biomass is good source of biogas productions. Biomass is capable of production of ethanol. Biomass is raw material for paper production even. The capable of phytoremediation of heavy metal is a quite attractive, emerging tool for synergistic green remediation of domestic sewage with resource recovery. Now, the pilot constructed wetlands for phytoremediation of sewage, that the methodology what we have done is, this is very interesting. I can share with you that this is a very simple technique tool that we can cross-check that efficiency of different macrophytes in a very simple method, that how we can judge that efficiency of different macrophytes with their very short time and very efficiently. And in this case, we have some students, those who have already worked with me, and myself standing with this during this constructed wetland. It's a pilot experiments. During the study, we have seen that some of these plants like Typha latifolia prove very efficiently within 48 hours of residence time, remove around 80%, 87% total suspended solids, and that can be, I can give you that phytoremediation data. Before that, I like to provide you the data, that methodology, that what we have done for this mimic form of this constructed wetland, pilot wetlands. Firstly, that round identical pot, each with 8 liters made of concrete, were designed to mimic the emergent macrophytes. Pots were perforated from the bottom and fixed on the stands with plastic pipe for the outflow of treated water. For suitable effluent flow, 48 hours retention time, each constructed wetland system, 2 pots are connected, combined to capacity of 160 liters. I mean, these are the methodology how we have gone with this constructed wetland in the pilot scale. In these pilot experiments, we have phytoremediation study. Pots were filled with raw sewage from overhead tanks and continued for a stabilization period of 7 days. For continuous sewage flow, the tank was refilled at an interval of 12 hours for 18 days. The treated effluent was allowed to move vertically downwards. This is the point to be noted, that here the treatment system was the effluents allowed to move vertically downwards. So vertical treatment wetlands. This is a pilot scale study where the raw sewage are allowed to flow vertically through the rhizosphere zone of the aquatic macrophytes, through the rhizosphere zone of CWS system. Finally, the phytoremediation effluent was discharged through a drain out pipe at the bottom and analyzed before the cultivation of microalgae. Now, during this study, some of this temperature experimental site, the temperature was minimum 14 degrees centigrade to a maximum of 32.5 degree, with a mean confidence level. The temperature for n number of the n number is n is the number of observations, and that was total mean value with having 22.8, with it mean standard error 1.25. Now, this is the data where the phytoremediation resulted the sewage treated sewage into this value. Here you can find the pH. The pH of the slow, the fresh sewage was 8.9, and after treatment it was 7.2, but in control it was 8.8, very insignificant. Similarly, the BOD in fresh it was 129.5 ppm, and it reduced to 42.1. And similarly, the very important part, that is the total substantial solid 305 to 38.2, total phosphorus decreased from 28.5 to 8.2, and ammonium nitrogen 84.2 to 46.8. Nitrate, it's very surprising. It is very interesting that nitrate was found to be non-detectable during this fresh waste analysis, but increased to the decreased to this it increased to the concentration 8.5, and just other one, that is the DO, dissolved oxygen, it was just a very low concentration, not detectable, and increased to the level 3.8 ppm, whereas the control it is very insignificant. Here, before going to getting this treated waste into a algal biomass, we have tried to have a pure inoculum of algae. Some of my students during the pilot scale study, we have selected that chlorella, that is one microalgae from the local surface water bodies. Although we have seen this wastewater after treatment, when it was kept for 1 week, a huge number of aquatic some algae, as well as some other types of that we can say pteridophytes are also growing around that waste. So I consider that after treatment, that macrophytes and also the algal communities are very much in large in number, and that must be, I think, must be due to this treatment of phytoremediation of waste. Before that, it was not having that more in concentration, neither in form of algal biomass nor the pteridophytes. But after treatment, it was very much emerging. It was very much surprising, wonderful that macrophytes and some microalgae are found very huge quantity. So thereby we have started to find that amount of growth. So we are curious that how much, in what condition it will be having more amount of that biomass of this microalgae. So keeping that mind, we have tried to separate that microalgae from that sewage pond, and then we have tried to grow in their control condition, and that is under patent. We have not yet disclosed it, that identity of that microalgae, and the total work is still, it is under process of patent, and we like to expose, we like to provide after a certain period of time, because it is under the process. Some of my colleagues, they are already in the process to get it patent. So this part is not completely shown here, but going to that next part, that's
Dr. Ajay, can you hear me?
yes, please.
Yeah, we are running out of time. Can you please complete in within 5 to 10 minutes? Because everybody is waiting for the lunch over here.
Thanks, sir.
It's not only virtual sessions, we are also having in-person sessions here, okay?
Yeah. So
We'll make it
this
fast.
is the methodology. I can show you that what are the steps we have gone to cultivate this algae in a control condition. This is the methodology. And the next one is the purification of that inoculum, where we have used some antibiotics, the chloramphenicals, the penicillins, and geranium dioxides to control diatoms. Then next we have gone to the control condition growth of that algal biomass, where we got, this is the figure, we got that around in mixotrophic conditions, we got the highest amount of biomass, that is 328 grams per liter. And in case of heterotrophy, the second concentration, the second amount of growth was found heterotrophic and then autotrophic. And the contrary is that the control, it was very less amount of growth we had observed. Here, this is the after my phycoremediation, means after algal growth, the level of treatment, how much the ammonium nitrogen, nitrate, and total nitrogen and total phosphorus removed from that original phytometric effluents, we have indicated here, and that can be very much clearly understood from this graph. This is the control, where you will find very less removal of these nutrients, whereas the treatment, it was very high, around 40% to around 15%. It is the biomass productions. So this graph is indicating the biomass productions, and where you can find this is the highest amount of biomass production, it was in treatment, whereas in control it was very insignificant. Variation in biomass production while chlorella, from this graph also it is very clear. You can find how much the quantity is produced in what treatment. This T1 is a mixotrophic treated, and T3 is T4 is T4 and T5 is the control condition. Similarly, this is the production, the similar trend you can find here. And reduction case, as I have told you, we find this is the reduction of ammonium nitrogen and nitrogen in final effluents. Here, this is the ammonium nitrogens and nitrogen. This is the brown lines. Similarly, this is the reduction of total nitrogen and total phosphorus from final effluents. You can find very clearly it is revealing that percentage of reductions. Similarly, the reduction of total nitrogen, that is decay in final influence of different treatment. So this is what we like to reveal, that it's very significantly in case of treatment, we can have the around 80 to 90% removal of this decay, which is a major issue in our current treatment system, where we are not effectively treating and thereby causing the damage to our surface water bodies. But here, if we follow this process, we can have 80 to 90% treatment of decay, and thereby the another product is that algal biomass is a very good promising biomass, can be converted into food, fodder, and fuel. And we have to focus on that, how efficiently and economically feasible that technique has to be evolved with coming years. So now, finally, to my conclusion, I like to tell you that result of harvested microbial biomass in treated effluents revealed a highest mean cell concentration, that is 2.6 gram per liter under mesotropic conditions, followed by heterotropic cell concentration, that is 1.8 gram per liter, with a lowest cell concentration autotropic condition, that is 1.2 gram per liter. Present study tend to suggest that the phytoremediation of domestic sewage in constricted wetlands integrated with mesotropic cultivation of chlorella species utilizing both light and carbon source has been considered the most suitable and efficient one. Finally, I like to share that our attitude, our common future, and it is our collective responsibility. Our dependence on nature is great, that we cannot continue to live without protecting Earth's environmental resources. Indian water bodies are severely degraded as a result of discharge of raw sewage from the urban communities. The consequent consumption of water is making city people more prone to the disease and health of the public health problems. So, in context of ever-growing population with dwindling water resource, we must adopt tools and techniques to increase efficiency of water use, to reduce, reuse, and recycle wastewater for sustainable future growth. The overpopulation and resource depletion in India urgently needing eco-friendly, multidisciplinary, and synergistic green remediation of its domestic sewage with resource recovery. Thank you for your patience, and I again express my great thanks and gratitude to the organizer giving me this opportunity. And I think through this platform, I like to attract the attention of across the globe, that in developing countries like India need a very serious level of thinking, that we need a very urgent eco-friendly approach for treatment of domestic sewage, where that waste from our domestic areas in residential areas can be converted into algal fuel for future, that is the third generation fuel. And because we have the huge population, we have the huge capacity to produce this type of algal based products, fuel, food, fodder, and fiber. And I keep with all this idea we have been focusing, and our near future, we are very much confident that we'll be perfectly achieving that for our future sustainable economy and sustainable environmental development. Thank you all.